Hello everyone. Today I will solve the question maximum length of repeated subarray. The question type is medium one and the question statement is given two integers array nums1 and nums2, return the maximum length of subarray that appears in both arrays. This question is like the maximum length subsequence question type, and here we need to return the maximum length of the repeated subarray, like here 3 2 1 and 3 2 1. It is the maximum length which is repeated in both the arrays, right? We have also one, but it is the length of one is only one, and 3 to 1 is 3. So we need to return the 3 maximum length of the repeated subarray. Here 5, because 0 0 0 0 5 times is repeated in both the integer array, right? So how we can solve this question? We can solve this question by using DP. So first I will explain you the solution in which the time complexity will be n cross m and the space complexity will be n cross m. But we will optimize the solution. The space complexity will be, and you can say n or m, whichever is lower in size. Here, like in this example, 32142, 31142. Here maximum length is 14, right? 14. The maximum length is 14. How we can solve this question using DP? So we will make a, if size is n and its size is m, n plus 1 m plus 1 DP array, you can say 2D array. We will initialize the first I equal to 0 and j equal to 0 with 0, because when there is a no digit, no integer, the longest subarray will be 0. Now we will check with this 3 to this 3. This 3 is same, right? It is equal. So we will make it 1. Now 3 2, it is not equal, so 0 0 0 not equal. Now 1 3 is not equal 0, 1 2 is not equal 0, 1 1 is equal. Now we will check for the previous digit. Is it equal 3 or 2? 3 or 2, this digits it will decide whether it is equal or not. It is 0, so it is not equal. We will put 1. So you can do one thing, you can add in this diagonal value for the whenever it will be equal, like here 1 3 is not equal, 1 2 is not equal, 1 1 is equal. Now we will check whether 1 2 is equal or not. This is not equal, so we will put 0. Now 0 0. Now 4 0 0 0. This was equal, so it will be 1. Sorry, it will be 1. Now 4 4 is equal. Now we will check for the previous one. 1 1 was equal and it was the 1. So we will add 1 and it will be 1 and 0. Here it will be 0 0 0 0. It will be 1 because 1 plus 1 is 1. 1 plus 1 is 2. Now 2 2 is equal, so we will add this and this will be 3. So we will return 3. But we can optimize it by using 1D array. Here in 1D array we can do one thing. It is 3. Our question is 32142, right? And it is 31142. Answer should be 1. Now how we can solve this question? We will take a for loop. It will start from here, and the second for loop will start from here. Let's say I and let's say j. For all this value, it will check from the back of this array. Now we will have the array of DP. You can say 1D DP. 1 2 4 5 1 2 3 4 5. Now we will check 3 to the we will check 3 to the integers of this array, but we will start from the back. 3 2 is not equal, right? So we will put 0. 3 4 not equal, we will write 0. 3 1 not equal, write 0. 3 1 not equal, write 0, and 3 3 is equal, so we will put 1. Now what we will do, now we will check this 2 with these digits of this subarray, but from the back side. Now 2 2 is equal. Now what we will do, we will check whether the previous digit was equal or not. 3 was equal or not. Was it equal? No. With these digits, was it equal in the previous case? No, it was 0. So it was not equal, right? Because we compared these two values previous time. It was not equal. So we will add 1 in this value. 0 plus 1 will be 1, right? So we will put 1 here. And 2 4 is not equal 0. 2 1 is not equal 0. 2 1 is not equal to 0. Now 2 3 is not equal to 0. So it will be 0 again. Now we will check for 1. Whether 1 2 is equal? No. Now we will put 0 here. 1 4 equal, not, it will not equal, it is not equal, so 0. 1 1 equal, so we will check for the previous digit. Yes, it is 0, so 0 plus 1 1. Now 1 1 equal, we will check for the previous, so it is 0, so 1. Now 1 3 not equal, 0. Now we will go check for 4. 4 2 equal, not, so 0. 4 4 equal, so we will check for the previous. Yes, previous digit was equal, 1 1 was equal, so we will increase this to 2. Now 4 1 equal, not equal, so we will make it 0. 4 1 is not equal, we will make it 0, and 4 3 is not equal, so we will make it 0. Now we will check for 2. 2 2 is equal, so we will check for the previous. Yes, previous digit was equal, and it was equal, previous two digits were equal, because it is 2, so we will add one more, because 2 is equal. Now our 2 2 will be 3. 2 4 is not equal, so 0. 2 1 is not equal 0. 2 1 is not equal 0. 2 3 is not equal 0. So in the last we will get one value. Everything will be 0, only one digit will be an integer, and that will be the answer. And we will also check every time what is the maximum, what is the maximum digit we are getting, so we will return the maximum. Now I am explaining this solution. So first, n1 is a size, n2 is a size. Here you can optimize it by using, you can make n2 is the smallest number, whichever is the low you can make it. I didn't do it here, but you can do it for optimizing more. Or you can make any subarray n1 plus 1 or n2 plus 1, because we need the lower in size. If it will be greater, there is no problem, but for optimization you can take it the lower in size. And we will for loop from the start and the second for loop from the end, and we will check if it is equal. We will check for the previous AP, like here it was checking for the previous int, and else we will make it 0, and we will return the maximum of answer, previously answer, or this dpj plus 1, and we will return that answer. Now I will run the code. It is exactly the same code which I shown you there. Now it's running. Thank you.